Statistics Unit, Section 3, Normal Distribution Applications. Knowing that a distribution is normal can be pretty handy to know. Here we have the heights of women in the United States, and manufacturers can use that to help them build and design equipment, cars, desks, and so on based on the size of the average woman in the United States. Manufacturers can also use that information to determine what kind of warranty that they will extend and their expectation of what they might possibly have to pay out should the item not meet up to the warranty that they've set. Here's an example of car batteries. They did some testing, and it turns out that the battery life is normally distributed. They're asking us how long does the average Sure Start battery last. Because of this bell-shaped curve in the center, we have the mean value, so our average is 50 months on average. That means 50% of these batteries will not last to 50 months, and likewise 50% of the batteries will last longer than 50 months. The next question asks, would it be better for this company to set a 54-month warranty or a 44-month warranty? Well, let's see where those marks fall. 54 is 2 standard deviations above the mean, and that means we have all of this area, and likewise a much larger percentage are going to expire before they reach 54 months in life. That's a lot of batteries that are going to fail that this company would be responsible for replacing, versus 44 is here 1, 2, 3 standard deviations below the mean. If you remember, 3 standard deviations above and below is 99.7. How many aren't going to make it to 44 months is going to be just a very small percentage. So for them to be on the safe side, that would be the better warranty for this company. Here's another example. We have lifespans of a 60-watt light bulb. It's normally distributed. The question asks, what would be the safest claim to make about the bulbs? Our bulbs are guaranteed to last 2,000 hours. Our bulbs are guaranteed to last 2,300 hours. Or our bulbs are guaranteed to last 1,550 hours. If they're not wanting to pay out for a large portion of these numbers, at 2,000, if it doesn't last 2,000, because 2,000 is in the mean, it means 50%, half of the bulbs will not reach that life expectancy for the bulb. 2,300 is even greater, which means there'd be a larger number of bulbs that would not make that. This company would be responsible for replacing a lot of bulbs, certainly over 50%. And then the safest claim as far as financial terms for this company having to replace bulbs that don't meet their guarantee, it says our bulbs are guaranteed to last at least 1,550. Is here on the low end. Just a small portion of them will last. So if you answered C, you would be correct. We have another application. They're asking us, after doing some analysis on the age of their customers, that the data graphed out in this bell-shaped curve, so we can use the characteristics of a normal distribution to answer these questions. The first one asks the average age. That would be in the center of our graph, which is 19. The next question asks what percent of your customers are between ages of 15 and 23. If we look at where those values are on the graph, we are 2 standard deviations below the mean and 1, 2 standard deviations above the mean, indicated by these hash marks. And if you look, that standard deviation is 2. Every one of these adjacent numbers differs by 2. The relationship for 2 standard deviations above and below on a normal distribution is 95%. The next question asks what percent of your customers are over 25 years. So we'll look to see where 25 is. 25, as it turns out, is 3 standard deviations above the mean, and they're asking us what percent is over this. So we're trying to determine what this region is here, over 25 years. To answer that, we know that 25 is 3 above. If we take 3 above and use symmetry, 3 below, the relationship for 3 standard deviations plus and minus the mean is 99.7%. Now that's the area between those two. To find this region and answer the question, we need to take 100% minus 99.7, and because of symmetry, that 0.3% is not only here in the region we're interested, but it also is here. These two shaded regions add up to represent that missing 0.3%, and we're only interested in half of that. So to answer the question, we have to take the 0.3% and divide that by 2, which it turns out our final answer is 0.15%. This is an extremely rare occurrence and would be something of note. Likewise, if we had a customer come in that was under 13, it would have the same 0.15%, extremely rare occurrence. A further question asks what percent of your customers are 15 years old or less. So we identify where 15 is. They're asking us for 15 or less, so we're looking for this shaded region. But we have to use the properties of normal distribution to answer this. So where is 15 located? It is 2 standard deviations below. If that's combined with 2 standard deviations above, that relationship tells us that that's equivalent to 95%. We have to use that information to then work our way down to answering the question. So if we know where 95% is, and the whole graph is 100%, the difference between those two percentages, in other words 100% minus 95%, leaves us with 5%. And those are here to the left of our 2 standard deviations below and to the right of 2 standard deviations above. This is double what we want though. These two areas combine to equal the 5%, and we're only interested in this shaded region to the left. Because of symmetry, all we need to do is to take that percentage and divide it by 2. So to answer our question, it would be 2.5% of the customers are 15 years or younger. The last question asks, if you sold to 15,000 customers last year, how many were between the ages of 17 and 21? Where do 17 and 21 fall? 19 is the mean. We are 1 standard deviation above and 1 standard deviation below. When we have that on a normal distribution, we're talking about 68% of the data. And this is true regardless if we're talking ages or light bulb lives or anything else. If it's normally distributed, 1 standard deviation is 68%. And then to answer how many, we will then take 68% of 15,000, which means we're going to multiply, converting that percent into a decimal. And it turns out there were 10,200 customers last year in those age ranges asked. For additional practice, Turn to pages 34 through 35 for application problems.